Let's look at some specific measures for reducing black carbon emissions and how other co-emitted compounds are affected. So black carbon is always a product of combustion, but it's part of the a bunch of emissions. So you have to look at other co-emitted compounds and how black carbon mitigation would affect those other co-emitted compounds. Okay, so the sectors are transport, residential, industry, and agriculture, and this is the measure that one would take. Diesel particle filters for road and off-road vehicles. Elimination of high emitting vehicles in road and off-road transport. Okay, replacement of coal by coal briquettes in cooking and heating stoves, so that greatly reduces particulate matter in the emissions. Pellet stoves and boilers using fuel made from recycled wood waste or sawdust to replace current wood burning technologies in residential sector in industrialized countries. So you can actually buy, for example, indoor heating fireplace to be run with wood pellets, which are made from recycled wood waste and sawdust. Introduction of clean burning biomass stoves for cooking and heating in developing countries. Substitution of clean burning cook stoves using modern fuels for traditional biomass cook stoves in developing countries. For example, in India, you would use dried up cow dung, wood, coal, and so on. So even sometimes just waste like paper and cardboard and so on and so forth. Substitution of clean burning cook stoves using modern fuels I already mentioned. Replacement of traditional brick kilns with vertical shaft kilns and Hoffman kilns. Obviously I won't go into the details, but they also trap the particulate matter and reduce their emission. Replacement of traditional coke ovens with modern recovery ovens. Ban on open field burning of agricultural waste. So we're talking about policies that are command based, and we have talked about the advantages and disadvantages of command based versus market based policies, but here this is regulation based. Okay, black carbon percentage contribution from various sources for 2005. Residential commercial combustion is almost 50%, transport is almost 25%, and then you have international shipping, industrial processes, agriculture, fossil fuel extraction and distribution, large-scale combustion, waste, landfill, and so on and so forth. So there are many efforts like this effort by Professor Ramanathan himself in India called Project Surya. In India, many languages including Sanskrit, Surya means sun, so solar power, sun. Fighting climate change now. So it's basically going after these methods of cooking where indoor pollution and even direct sparks flying and hitting the eye. My own mother had a severely damaged eye for almost 30 years till her death from a spark. So there is huge evidence of health effects of indoor pollution from this kind of biomass burning wood stoves and cow dungs, dried up cow dung being used and so on. And there is also the Clean Cooking Alliance, which is also an NGO that runs the efforts to reduce black carbon from cooking. Measures aiming to reduce black carbon also include improved biomass stoves, modernizing coke ovens, removing big smoker vehicles like this, cooking with clean fuel, upgrading heating stoves to pellet biomass, improving brick kilns, reducing flaring. As we said before, flaring where excess methane is burned off or any kind of emission from various sites like waste treatment or production of oil and gas, reducing agricultural burning, and replacing coal with coal briquettes. Okay, so just to look at some black carbon emission trends, this is the 2015 black carbon emissions from main anthropogenic sources in million tons by region, historical trends and projections out to 2030 under business as usual, and full-scale SLCP mitigation scenarios. Lots of information there, but different regions: Latin America and Caribbean, North America and Europe, Africa, Southwest and Central Asia, East Asia, Southeast Asia, and Pacific. So you can see that the good news is that there is some positive news on biomass cook stoves and biomass heating stoves and so on. So those are the negative numbers there where emissions are being reduced, and the 2030 projections. So households had 58% of the 2015 global emissions, and main sector here, for example, was biomass cook stoves in Latin America and the Caribbean. The projections look good, so projected percentage change from 2015 to 2030 under mitigation scenarios is this blue circle here: minus 56, minus 73, minus 68, minus 65, and minus 62, with some projected percentage change from 2015 to 2030 under business as usual also being negative here in some parts. We have to understand where that comes from, why business as usual would still reduce black carbon. But you can see that the percentage change from 2000 to 2015 is positive here, negative in North America and Europe, which is good news. Africa has positive, and these places, this has positive 12%, whereas East Asia, Southeast Asia, and Pacific have minus 2%. Okay, so kind of a mixed message, but it's clear that the reductions by 2030 compared to business as usual from 2015 to 2030 can be substantial if full-scale SLCP mitigation measures are taken into action. Okay, that's what we want, right? Black carbon is something that seems so obvious. It looks ugly, it immediately hurts you, harms you, and should be eliminated, and impacts can be seen within weeks. If emissions are reduced, black carbon has a residence time of a few days. If emission is reduced, positive impacts and co-benefits can be seen literally in weeks.